Hello everyone, and welcome to another remote sensing lecture video. And in this remote sensing lecture video, I want to continue our discussion on the error matrix by talking about some accuracy measures. And so what I've done here is I've incorporated this idea of row sum, column sum, the total, and the diagonal into our error matrix so that we don't have to recalculate them and everything's a little bit cleaner. So what I want to do is I want to talk about what we actually can do now that we have these summations, right? We've fleshed out our error matrix a little bit more. So let's talk about what we can do with all of these values, okay? And so what I want to do is I want to draw your attention back to the fact that the diagonal of the error matrix, right? These numbers are once again, right, where the model was right. And I keep coming back to these because this is going to be really important in understanding what we're going to be doing next. So we can do three things. The first thing that we can do is we can take the total, or we can take the sum of the diagonal. Actually, let's do that in a different color. Right, we can take the sum of the diagonal divided by total. This is the first thing we can do, right? So we can pull this 40, and we can pull this 27. Right, so if we do that, I'm going to scroll down just a little bit because I want to give us a little bit more room to work with. Right, if we take the sum of the diagonal divided by the total, so that would be 27 over 40. Right, if we pull out our calculator and do the math on that, right, 27 over 40, we would get 0.675. Or, right, we could do 67.5%. Right, all I did was move the decimal place over 2 to make this into a percentage. Now, you might not understand what I just did, and that's okay. I want to step back and I want to walk kind of through what we did and why we did it. All right, so I didn't just randomly pull out the sum of the diagonal and the total. I did that for a reason. And again, right, this diagonal is where the model got it right, and the total here, this 40, right, that's the total number of chances that it had. Right, so put another way here, what we did is we took the number correct, right, because that's the sum of the diagonal, divided by the total opportunities. Right, so put another way, right, taking the number that we got right divided by the total, right, you can think about this just like a homework assignment that you turn in, right? When you have the number that you got right divided by the total number of problems, right, that's your score, right? In remote sensing, we call this the overall accuracy. Right, we call this overall accuracy. And I'm going to write that down here again. 67.5%. And again, overall accuracy is the number correct divided by the total. Okay? So that's one thing we can do. I'm going to use purple here. Now I want to look at going across a row. Right, I want to look at going across a row. And so if we take, for water, for example, if we take the row correct, which I'm going to call row core, divided by row sum, right, so we're pulling this number here, and we're pulling this number here. Right, if we do that, we get 7 over 7 which is equal to 1, which is equal to 100%. I'm realizing the percent sign might be cut off a little bit, but it's 100%. Okay? So let's talk about, actually let's go ahead and let's do another one. Let's do forest, right? So it's the number correct, which in this case is going to be 6, right? Because the number correct in this row is 6, divided by the sum, which is 11. So 6 over 11, right? It's going to be this number here and this number here, right? 6 over 11. If we pull up our calculator really quickly and we do 6 over 11, it's going to be 0.54 repeating, so we're going to round that to be 0.545, which is going to be the same as 54.5%. Right? Let's just take a step back for a second and think about what we just did. Okay? So what we just did was we took the number that were right in that row, right? That's where in this row in particular, right? It's the number that we said were forest, that the map, right, that the pixel was actually classified as forest. That's the number that was right, again, right, looking at the diagonal, divided by the total number of pixels that the map thought was forest. Okay? So we call this number user's accuracy. Right? And we're going to have the entire next video is going to be dedicated to explaining this concept of user's accuracy and then the concept of what we're about to talk about in the next video. Or sorry, in the next step here. Right? So if we take the number that was right in a row divided by the total of that row, we get what's called the user's accuracy. Okay? So the last thing that we can do, and I'm going to use orange here, right, is we can take the column correct. Oh, actually, I already used orange. Let's do blue. All right, we can take the column correct, which I'm calling column core, over the col sum. Right, so to be clear, we're taking this number, we're taking this number. Right, that's 7 over 10, which is going to be 0.7 or 70%. Right? So let's take a step back for a second and think about what we've done here. Right, in this case, again, right, the column correct, this is the number of times that we said that it was water, that the map also said that it was water. Right? The col sum in this case is the total number of water validation data that we provided. Okay? Number correct divided by total number that we provided. So this is often called the producer's accuracy. Right, called the producer's accuracy. And again, the next video is going to be delving more into the definitions of what these things mean. Okay? So hopefully that makes sense. Actually, you know what? Let's do one more example of producer's accuracy. So for forest, right, it would be 6 divided by 4, or sorry, 6 divided by 10, right, because it's the number correct divided by the column sum, which is 0.6 or 60%. Okay? So hopefully that makes sense. Hopefully you understand where these different pieces are coming from. Again, don't worry necessarily about interpreting them yet, but just make sure that you understand mathematically what we're dividing and why we're dividing it. Okay? Hopefully that makes sense, and if you have any questions, please reach out. Thank you.